So when we want to isolate that variable of z, we have to get rid of the thing that's bothering it. The thing that's bothering it is the 7. We divide both sides by 7. What do you get when you divide 49 by 7? 7. Nice job. Next up, we want to isolate that variable again, but now that variable is x. What is my first step? Yep, Raj. We're going to add 4. And what you're going to add 4 to both sides, you know I'm going to have to move this over to the side because I write large. We end up with 2x equals, what is 18 plus 4? 22. Okay, and then our last step here is dividing by 2, and you get x equals 11. Nice job, team. Okay, so on these, when you have other things happening, like addition and subtraction, you're doing the reverse order of operations. So PEMDAS, so parentheses, exponents, multiplication, division, addition, subtraction. So you're doing it reverse, so you did addition, subtraction first, and then you moved on to multiplication and division, and you continue to work that direction. And then after that, our last one of this type, we have y plus 5 equals 27. What's my first step? Subtract 5, thank you. We end up with y equals 22. So after this is evaluating expressions or evaluating variables. We want to find the point. So they tell us that x equals 2, y equals negative 1. What do I do with that information? Yep, Kevin?
Replace the actual variables with the given number.
Exactly right. Replace the actual variables with the given number. So we're going to substitute in. So you have 2 plus 2 over 2. And then you have negative 1 minus negative 1 over 2. So 2 plus 2 is 4 divided by 2. Okay. And then negative 1 minus 1. Negative 2. Divided by 2, which is? Negative 1. Yep. So our first answer is 2 comma negative 1. I know it's a little low on our screen. And then our second one, we're going to do the exact same way. With the substitute in, we have 2 minus 4 over 2. And we have negative 1 plus 5 over 2. 2 minus 4. Negative 2 over 2. And then negative 1 plus 5. 4 over 2. I'm going to write my answer above it right here so you can see it a little clearer. Negative 2 divided by 2. Negative 1. 4 divided by 2. 2. Okay. Okay, so our first part here is our section today is 2.1, segment bisectors. And your objective that you write at the top of your page on that OBJ section is to bisect a segment and to find the coordinates of the midpoint. So today that is what we are working on. So we have our vocab. Our first word is to bisect. To bisect is to divide into 2 congruent parts. What does it mean to be congruent? Yep, equal measure. So when we divide it into 2 congruent parts, we're dividing into 2 equal parts. We have a segment bisector. It's a segment, a ray, a line, a plane that intersects a segment at its midpoint. So it is what is doing that bisecting. It's cutting it into 2 congruent parts. And that last part is the midpoint. The point on the segment that divides it into 2 congruent segments. So it's that point of intersection or just a point there that's going to divide it. And the midpoint can be found using this formula. Looks a lot like our bell ringer formula. x1 plus x2 divided by 2. y1 plus y2 divided by 2 lets us find that midpoint. K is our midpoint. If it is our midpoint, what do we know about this segment here, FK and KG? That they are? They're going to be the same. What's the word we use for that? Congruent. So what we use to show that in pictures is a little tick mark. And generally it is called a tick mark. Sometimes they call it like a hash mark. But tick marks are pretty generally accepted. And that shows that this segment here is congruent to this segment here. If we know the whole thing is 36 and it's comprised of 2 congruent segments, how do I find the measure of each part? Raj? Divided by 2, exactly, right? So she took 36. She divides it by 2. What value do we get? 18. So we see that the value of our length of FK is 18 and KG is 18. You can double check this by adding those two back together and you'll find that the total length is going to be that 36. So we showed that they were congruent by the tick marks. Then we set them equal to the 36. We divided it by 2 and we found 18. For our second one, we see that M is the midpoint of segment JL. We want to find the length of JL and ML. If it is the midpoint, what do you know about the two segments? They're congruent. So once again, we can draw that little tick mark in. It tells us that they are congruent segments. So if they are congruent, then what is the length of ML? 7. So I'm going to write explicitly ML equals 7. And then we also want to know the total length of JL. How do I find that? We're going to add 7 plus 7. Yep. So 7 plus 7 is?
14.
Nice job, guys. So we see the whole length of that segment is 14. Because it's the midpoint, we know that they're both 7. To find the total length, we just add them up, and we end up with 14. Okay, so if line S is the segment bisector of FH, what did it do to the line? It cut it in? Yep, it cut it into half, cut it into 2 congruent segments. So once again, we show that they're congruent by putting those little tick marks. And since they're congruent, what can I do with them? So we could add them to find the whole length. If I'm wanting to find just the X. So that goes along with it. But what do we know about this part here? If it's congruent to this, how much does this segment have to be in total? It's going to have to be 36. So to solve for this, we can take 9x, or I said it equal to 36, because if they're congruent, they have to have that same measure. So we're going to do 9x equals 36. From here, now what can I do? Divide by?
9.
Thank you. X equals 4. And again, we can double check this. You can plug 4 in here. 4 times 9 is going to be 36. And we find that's going to be 36. It does not ask for it. But if I wanted to find the total length of FH, how could I do that? Add? What am I adding? 36 plus? 36 plus 36. So my total length of the segment would be? 72. Nice job. Our first step up, we see that line L is the segment bisector of AB. So if it's a segment bisector, what do we know about these two parts? That they are going to be congruent. So remember that we marked that with that little tick mark. You're going to show that you know they're congruent. Since they're congruent, what can we do? Set them equal. So we have 5x equals 35. Next step. Divide by 5. X equals. And so this is all the question actually asked, was for you to find that. But let's say we wanted to find the total length, which I saw a number of you do. So if we wanted to find the total length of AB, how did you find it? Yep, we're going to add 35 plus 35. And what did you get? 70. Since we know that those segments are congruent, we know both of them have that measure of 35. You can test it again by plugging in 7. We added them together, and you got 70. Nice job. Okay, after this, we have a different style of question. I'm going to make a line down the wall so I don't spill into the other part of the question. Yes, ma'am? So for this next part, we're going to do find the coordinate of the midpoint of the segment GH. On the definitions page, I gave you that formula. Can anybody tell me what that is? I'm going to write it right here so we have it. So on that definitions page, what's our formula? Somebody from the FAR group over here. I feel like I'm neglecting you today. Yep, Jasmine. Nice job. Comma. Nice job. She is 100% correct. And then I want you to remember something real quick, because over the summer you might not have remembered it. When I write out a coordinate point, what comes first, X or Y? X. And what comes second is Y. So if it's something you forgot, please remember it. You can write that little note on your page. So if we want to find the coordinate of the midpoint of GH, we know this is going to be X1. This is going to be Y1. This is going to be X2. This is going to be Y2. So I'm now going to set that up. We have 4 plus negative 3 over 2. And then we have 0 plus negative 1 over 2. What is 4 plus negative 3? 1 over 2. And then over here we have 0 plus negative 1. It's going to be negative 1, right? Over 2. Because when we're adding 0, it doesn't affect the number. So we're going to have 1/2 negative 1/2. I do not ask you this on this page, but I promise that I give you a question like this sometime in the future where I ask you to graph it. So we're going to graph it together. If you need to make a coordinate system to the side, a coordinate plane, so you can graph it, please do. So we see our points are G, which is 4, 0. You're going 4 in the x direction. 1, 2, 3, 4. Kevin, can you see that blue okay?
The blue?
Yeah. Trinity, can you see it okay back there? Okay. And Natalie, can you see it back there? You guys are my furthest back. Okay, so this is going to be G. And then my H is negative 3. So we're going to the left. 1, 2, 3. Negative 1. I'll place it right here. It's going to be my H. You have the advantage of having a straight edge as your ID. You all should be having those. And then we're going to use my eraser because it's the closest thing I have. And you're going to connect those 2 points. That is a little brutal. Hopefully yours turns out a little nicer than mine. So on there, if I wanted to find that midpoint, it's going to be at 1/2, negative 1/2. So at 1/2, it's going to be at negative 1/2. It's right about here. And that's going to be my midpoint M. So if I asked you to graph it, this would be a good way to verify that your point's at the correct spot. My graph looks pretty close, even though my line's a little lopsided to what the point is we arrived at. Over here, we're going to do the same thing. We now have negative 2, 3, and 4, 8. So I'm going to switch my color. We have x1, y1, x2, y2, negative 2 plus 4 over 2, 3 plus negative 8 over 2. 4, or negative 2 plus 4 is 2 over 2, which is 1. And then we have 3 plus negative 8, negative 5 over 2. Is there any numbers we can take out of that fraction? So technically that's in its lowest terms as an improper fraction, but we could write it as a mixed number if that helps you graph it. So what would my mixed number be? Negative 2.5, or you could leave it as that negative 5 over 2. Either one of these would work. And then we're going to graph it again. I'm going to erase some of my stuff from above, and then I'll graph it above. So if you need to draw out your coordinate system, please do. This is the time where you draw your X and Y axes. Hint, hint. Wink, wink. Because I draw it, you draw it. So my points are negative 2, 3. So 1, 2, 1, 2, 3. G, H is 4, 1, 2, 3, 4. Negative 8, 1, 2, 3, 4, 5, 6, 7, 8. H. Connect my points with the line. And then we're going to plot my midpoint, which is going to be that 1, negative 2.5. So when X is 1, Y is going to be negative 2.5. It's going to be right around there. And we see that's going to be my midpoint. So once again, we can verify that with our graph.